Okay, so now let's look at creating some kind of relationship between the curve that we have and these cuboids. And actually, we're not going to use the cuboids because they have multiple points along them. I'm going to actually turn the preview off on the cuboids and turn the preview back on about the coordinate points. And now we want to get an idea of some kind of relationship between this point and the line. And one of the techniques we can use is this idea of the closest point. What is the closest point between this line and this line on the floor and any given point up here? So bear with me just a second as we go through this, and it'll become a little clearer once we complete a couple of steps. And I'm going to actually search what is called geometry closest. And actually, I'll close that off and I'll redo the search. Dot closest, and you'll notice what pops up here if I roll on it. It just shows you it creates a relationship between two objects with the shortest path between them, the closest points that could be connected with any kind of a string. Any other points on either object would have to be longer. So it's a quick way to come up with some kind of a relationship between two objects, which happen to be a line and a point at this point. It's a really powerful piece of computational tool. So what we want to do is relate the NURBS curve to these points up in the coordinates. So I'm going to use the NURBS curve as the geometry, and I'm going to use the point coordinates of the grid as the other geometry. And when I do, I get the indication. I'm getting a bunch of things showing, but you're not seeing them all. Actually, I think if I turn off points by coordinate, no, they won't show up. The other points, excuse me, a little detour there. I'm not seeing the relationship between these two. The way I'm going to make that visible is going to draw a line between these points. So I'm going to do, I'm going to right click and do a line by start and end point. It's the first thing that pops up. So now we have all of these endpoints on the NURBS curve, and our start points can be the grid points. And when we connect them, now we have all of those closest points to each given point to a relationship on a NURBS curve. And let's just take a look and examine what we've got here. I'll just zoom in, and we can roll around this a little bit. Let me do the orbit command. All right, and you can see some things make real good sense. Like all of these points, the shortest point is that center point of the NURBS curve that we created. A little bit more difficult are what happened at these end conditions and their connections to the short connections to that coordinating point there. But that gives us now a whole bunch of various lines which have lengths to them, and we can use those lengths to determine the lengths of our ceiling panels. So once again, we'll go back to the node programming, and the next thing we want to look at, and once again, let me just click on something, it'll change this back to an arrow. We want to get an idea of how long each one of these lines are. We don't really care so much about the lines, we care more about the length of the line. So I'm going to use another quick search and find out what the curve lengths are. Curve, maybe dot length. There we go. So I can put a curve in, and a curve and a line are really the same thing. And now I'm going to get an output of a bunch of curve lengths. Let me just show you those again. All right, and so it makes sense. They go as short as 20 feet. That's the distance between the floor and the ceiling at the shortest path that could possibly happen. And then the longer paths are the ones that are more offset from that curve. Now we have a number that we can actually use to drive the length of our cuboids. So I guess I just want to stop for a second. I'm sure that a lot of you are overwhelmed by these terms that I pulled out of the air. It is a technique that you will become accustomed to in the future because you'll realize that there's relationships between things, and that's what you want to drive your solution with. And so you will become much more familiar in the future with this idea of the start and end point of a line to make a line between them, a bunch of points to make a NURBS curve, that sort of thing. So maybe just take a breath if you feel like you're a little bit overwhelmed. Just generally, I guess, enjoy the idea of connecting things and watching things change. So we have that curve length, and we have a length to our cuboid, or actually it's a height. So let's go ahead and connect those and see what happens. And I need to turn the preview on for this so that we see it. And now I'm going to select the object command and zoom out. And now you can see how our tiles now have all different lengths to them according to their relationship to that NURBS curve. So the problem is they're all 20 feet long. Let's just make a quick adjustment to that, just a mathematical adjustment to it, and we'll end this clip. So I'm going to, oops, sorry, I just slip back over to our graph, and let's insert an extra element here. I'm going to do a little bit of math. Each one of these is at a minimum 20 feet long. So I want to subtract out that amount just to get these down into a much shorter range. And I'm going to use code block again. So I'm going to do code block. And I'm going to do math. So I'm going to go x equals, oops. X minus 19. And then colon. And I'm going to take the curve length and call that x. And now our output will all be numbers that are at the least 1 foot. So I'm taking what was 20 now, and we're left with 1 foot. So now I can take that code block and connect that to the height. And now all of our ceiling tiles are much shorter. So let me zoom in here. And we still have some problems with that, and we're going to correct those in the next couple of videos. And that is, they're going up and down, but we've already started to create that idea of our variable geometry to our curved elements. So in the next clips, we'll look at how to make those adjustments to our tiles.